This is the equation of E1-6, exercise E-1-6, okay? We are going to continue E1-6, which is based on the figure that we have discussed in E1-1 before, okay? Before this, in E1-1, we didn't discuss about inductance, finding the inductance, okay? So for this, based on the exercise E1-1 before this, the question is calculate the inductance, okay? So we want to calculate the inductance. A based on E1-1, calculate L. Before this, we didn't calculate L. So now we are going to calculate L. Okay? So remember the equation of L is lambda over I. Okay? So we can just further compute it in terms of n phi over I, and then finally n square over RC plus RG. Okay? So how to compute this? We just need to follow the previous discussions. Okay? So basically L is n square over RC plus RG, which is R tot lah. So this RC RG is actually R tot. Okay, so in this case, we just need to calculate it by substitute all the values given. So 500 square divided by, so RC plus RG, before this we have got that value of RC by RG in the exercise E-1, E1-1, which is 4.46 times 10 to the power of 5. You can just have a check, betul ke tak? 4.46 darab 10 power 5. Okay, so we get here L is 0.56 Henry. So that's it for L. So note that, let me just write something here. Note that in this case, core reluctances is relatively smaller than gap reluctance. Thus the good approximation of inductance is dominated. Dominated. So the inductance is dominated by the gap. The gap reluctance. The gap reluctance. Apa? RG lah. Dominated by RG. So now in this case, we just instead of dividing by R tot here, since RG is dominating, this RC is small enough. This RC is small enough compared to RG. Then we can just assume that it is actually L. We can just calculate L as n squared by RG only. Alright. So in that case, 500 square divided by RG is from E1-1 before this. We have found that RG is 4.42 times 10 power of 5. So in that case, we get 0.57 Henry. Alright. That is A. Find the inductance. So in this question, also we need to find B. What is B? The magnetic stored energy, W, for BC equals to 1 Tesla. So we want to calculate W. What is W? It is a magnetic stored energy. So remember, the magnetic induction, it will become an energy storage. So remember, we have the inductance L. So the stored energy, in this case, do we consider energy is E? No, we use W. The magnetic stored energy W is half of Li square. Remember that equation? Okay, the magnetic stored energy. So this case, given that BC, okay, this is just to make sure that you all memorize the equation. Just this is inductance, but actually we are talking about this core with air gap. Okay, we are talking about this core with air gap. So just highlights, just list down all the values given. BC is 1.0 Tesla. Magnetic flux density of the core. Given also current I is 0.8 ampere, which is from the calculation that we got from E1-1, exercise 1-1. So therefore, we know that W is half of Li square. Okay, just we need to substitute. Okay, L, what is L in this case? 0.56. In the previous case, we just use this one, this L. Okay, 0.56. I square is 0.8 square lah. Alright, so you can get by using your calculator ataupun congak dalam kepala saja. 0.18 joule, 0.18 joule, the magnetic stored energy. Okay, that is the magnetic stored energy. Okay, alright. C. What is the question of C? The induced voltage E. Voltage induced E. The induced voltage E for a 60 Hz system, 60 Hz, time varying core. Time varying core flux of the form. Before this, the flux BC we consider as BC is constant. This is not time varying. But for the case of C, BC is now time varying. BC is time varying. Something like that. The sinusoidal punya waveform. So in this case, BC is 1.0 sin omega t Tesla lah. Alright, where omega is 2 pi f, which is 377 radian per second lah. Okay, so we have the information. Then we need to find E actually. E is the flux linkages, the rate of change, the flux linkages. E d lambda over dt. Okay, and for sure lambda is n phi kan? Ingat tak? Lambda is n phi. So just substitute d over dt, substitute lambda, which is n5, n5. Then we can just put n outside, d phi over dt. Okay. So do you remember that another equation is phi equals to BA? right? So we can also substitute phi in this case. So E is N, D, phi is BA. So in that case, BA of the core, BC is C lah. Okay, phi equals to BA, D over DT. Alright, like that. So, take out A outside, dBc over dt, like that. And once we get that form, we can just substitute, which is 500. We also have AC, which is 9 times 10 to the power of -4 for AC. And given that BC is time varying, which is 1.0 sine 377t, omega is 377. Alah, sekejap betulkan sikit, bagi cantik sikit. Okay, betul tak? Okay, now as you can see here, so this is saya kena betulkan sedikit kat sini just wait a second. I'm going to fix this. I'm going to put this a bit ada space kat situ. Okay, so that this is actually the rate of change of BC, right? The rate of change of BC, d dt of BC. Ingat tak derivative of sinusoidal waveform? Okay, ingat tak? Okay, teruskan 500 9 kali 10 negatif 4. The rate of change of sin 377t, take the derivative, kita dapat 377 cosine 377t. Kalau tak tahu pasal ni, buka balik buku calculus, trigonometric punya identities, trig identity. So just simplify the constants there, we get 170 cosine 377 377t volt. Okay, so this is the voltage, induced voltage. Okay, that's it. So that's all for E1-6. Okay, so thank you. Aku nak habiskan kat sini je. Okay, bye. Assalamualaikum warahmatullahi wabarakatuh.